Hello, today's lesson we are talking about how to prove triangles similar. So remember, similar means that all of the sides are proportional and all of the angles are congruent. So we're going to go through some similarity theorems and postulates. So our first one is called the angle-angle similarity postulate. It says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So if angle T is congruent to angle P and angle R is congruent to angle L, then I know triangle TRS is similar to triangle PLM. Now remember, they can be different sizes. And also remember, we had that one theorem that told us if two angles of one triangle are congruent to two angles of another triangle, then the third angle is congruent, right? Because they all have to add up to 180. So we already know angle S and angle M are congruent, but we only need two to prove that the triangles are similar. So explain why the triangles are similar in this example and write a similarity statement. So a similarity statement is basically like this right here. Triangle TRS is similar to triangle PLM. So if I look here, we have one angle. So we have angle R is congruent to angle V, and we also have vertical angles. So we know angle WSR is congruent to angle BSV. So then I have angle-angle similarity. So I can say that triangle WSR is congruent to triangle, got to make sure I go in the correct order, BSV by angle-angle similarity. Okay, so when I explain why, I am listing both the sets of angles and the postulate or theorem. And then when I write my similarity statement, that's this piece right here. All right, let's read our next two theorems to show triangles are similar. Theorem 7.1 says is the side angle side similarity theorem. It says if an angle of one triangle is congruent to an angle of a second triangle and the sides including the two angles are proportional, then the triangles are similar. Let's draw a picture for this one. You can do this in your composition notebook, or you can snip it and put it in your Google Doc if you would like. Okay, so if I have one triangle, and then I have another triangle, and it says if an angle, so let's pick an angle, is congruent, and the sides including the two angles are proportional. If one angle, one triangle, okay, the sides including the two angles, so that would be this side here, so we'll call this A, and this side B, so those two, and then this side here, and this side here, so C and D, are proportional. So that means if I compared A to B, that would be the same as C to D. Or remember, you have all of those other ways to do it. So I could say A to C has to equal B to D, however you want. But this would be typically what we would do. We would put from one triangle to another. The corresponding sides would make their own fraction. Okay, so that's what that would look like. So then we have the next theorem, which is the side-side-side similarity theorem. It says if corresponding sides of two triangles are proportional, then the triangles are similar. So for this one, in my two triangles, let's copy these triangles here. Where's my copy button? I don't know where my copy button is. I'm just going to drag them down. And then we're going to add another side. So let's add side E and F. So then here, my proportion would need to include all three sets of sides. So I would have A to B, right? Those are corresponding. And I can erase this angle because we don't know an angle is congruent. And then I would need to have C to D. And then my last side would be E to F. And all three of those fractions would have to be equal in order for those triangles to be similar, okay? And so make sure that you're always matching corresponding sides. And if you notice, all of the values on the top, all of the numerators come from the small triangle, And all of the values on the denominator come from the larger triangle. And that's another way to make sure your fractions are organized, your proportions are organized, is to make sure all the numerators are from one triangle, all the denominators are from another, and each fraction is corresponding sides. All right, let's do some examples. So explain why the triangles must be similar and write a similarity statement. Okay, so if I look here, I have an angle, and now I need to check that my sides are proportional. So I'm going to highlight my corresponding sides here. So that corresponds to that, and that corresponds to that. So if I look 3 to 4, okay, so I got small triangle on top and big triangle on the bottom. If I could spell big correctly. And then I have the yellow sides, or one fraction, and now my blue side, so I got to make sure it fits the same scenario. So 6 is on the small, 8 is on the large. And those two fractions are in fact equal. So yes, so check. Okay, we got proportional sides. We have an angle because it's a right angle, so I need to make sure I state that. Angle R is congruent to angle Y, okay, because they're both right angles. So then they are going to be triangle PRQ is going to be similar to triangle ZYX. Okay, by this would be side, angle, side, and then we put the little similarity symbol after it so that we don't get it confused with the side, angle, side congruence theorem. Okay, next one, find the length DE. All right, so let's check that these are similar. So I have an angle here, which is fantastic. So now let's see here. So I know that angle ABC is congruent to angle DBE. And let's check. So if I have corresponding sides here, so when I look at these corresponding sides, I'm going to look in terms of which one's shortest. So on that angle, 18 is the shorter side and 12 is the shorter side. So I'm going to compare 12 to 18. And then I'm also going to compare the other sides that touch that angle, 24 to 16. So I'm going to make sure I put 16 on the numerator because it's from the smaller triangle. Okay, so then if I reduce my top fraction by a factor of 6, I get 2/3. If I reduce my bottom fraction here by a factor of 8, I also get 2/3. So I have that my triangles, so triangle ABC is similar to triangle, let's see here, EBD. Okay, and that is by the side angle side similarity again. All right, so now my goal is to find DE. Well, my similarity ratio is 2/3, so I'm going to use that. So I know when I go from the small triangle to the large triangle, the proportion of sides, of corresponding sides, needs to be 2/3. So I know 10 over whatever the length of DE is has to equal 2/3. Okay, so then I can go ahead and solve that proportion. I'm going to cross multiply. So 10 times 3 is 30 equals 2 times the length of DE. And then I'm going to divide by 2. And I get 15 equals the length of DE. Okay. So whenever you have to find a side, if they don't already tell you the triangles are proportional or the triangles are similar, you need to go ahead and show me that those triangles are similar in order to find that missing side. If they tell you the triangles are similar to start with, you don't have to go through this work here, okay? This work would be unnecessary. So that's just to show that they're similar so that you can set up your proportion to begin with. All right, next one. Find the value of x in the figure. Okay, so here we have angle-angle similarity. So we know my triangles are similar by angle-angle similarity. Okay, I don't have to do any work to show that. It's already marked. So now I can go ahead and set up my proportion. So I'm going to match my corresponding sides. So x is the side between the two marked angles. So that's going to match with 6. And 8 matches then with 12 because it's the other one on the single arc side of that angle. Okay, so then when I set up my proportion, I'm going to go small triangle to big triangle equals small triangle to big triangle. And then I'm going to go ahead and cross multiply. So then I get 6 times 12. 6 times 12 is 72, I believe, equals 8x. Divide both sides by 8, and I get x equals 9. All right, fantastic. Example E, in sunlight, a cactus. Ooh, I get to draw a cactus. This is exciting. I like cacti. Here's my cactus. Okay, there we go. Here's my cactus. Maybe my cactus needs some spikes. There we go. There's my cactus. Okay. Cast a shadow of 9 feet. So let's see here. Ooh, let's make it shadow sparkly. Sparkly shadow. Okay, so we got 9 feet here. At the same time, a person 6 feet tall cast a shadow that's 4 feet. Find the height of the cactus. Okay, so we got our sunshine here. We need some sunshine. All right. Okay, so find the height of the cactus. All right, so here we're going to have similar triangles because if I look at these are both right triangles, right? So I'm looking for x here. I have an angle here. Okay, and they're going to be similar because the sun is still at the same height. So when I go ahead and connect these triangles, hold on, my top parts are too tall. So when I connect these triangles here, there we go. Now we have triangles. So then I'm going to have my corresponding sides would be x to 6 equals 9 to 4. Go ahead and cross multiply. 4x equals 54. Divide both sides by 4. And since this one has units, go ahead and use a decimal, right? So our units here are feet. So when I go ahead and divide 54 by 4, I'm going to get 13.5. So 13.5 feet is how tall the cactus is. All right, so go ahead and try the homework after you are done submitting your classwork.